Hi everyone, welcome back. In the previous video, we went through how we can create a simple boilerplate where we created our first flask object, and this flask object was used to expose one route called option price, and we attached a function to be tied to that route such that that function is called if our users hit that route. So as you can see, this is the function that we have attached to this route over here, and if our users hit call option price, they will get back a static output of the apple's price. So let's try spinning up this server to demonstrate that. So currently we're running the server on port 6000. Let's navigate to Insomnia, our client tester, and let's make a request. So as you can see, our server currently returns back the static price of Apple, hard-coded to a price of $100. So to be frank, this current state of the application is not helpful at all. Currently, it's returning back a static value and it is not being responsive to the input of the user. It might have been more useful if our users were given the opportunity to pass us a stock that they're interested in, and based on that, we return back the price of that stock. So for this video, we'll be focused on the concept of editing our server so that it can get the input from our client, and with respect to this client input, we will change the output of our server accordingly. So with that, let's get started. The first step will be to figure out how we can get the input from our client. So to do that, we can do from flask import request. And this request over here is corresponding to an object of type request that has information regarding our input from our client. So to do that, we will assign this to data. So this data that we're going to get from the request right here is of type bytes. So it is a raw formatted data that is not deserialized to a dictionary of sorts. But regardless, to get it, we will do request.data. And if you are curious, this request over here is within the Flask package, and if you inspect this data function over here, you see that this is under the work0 library, which is part of Flask dependencies. But in short, this function returns back the incoming request data as string or bytes in this case you came with a MIME type. Okay, that is too much the information, but in short, what it does is it gives us back the raw data that is passed to us by our user. So your next question that might come to mind is, how does this data look like? So assume that we have a documentation and we communicated to our client that they should pass us data like this. Let's say a JSON-like formatted data of type bytes or strings. And this dictionary will contain a key called stock, followed by the name of the stock that they wish to get the call option price for. So let's say Tesla. So if they give us this, then we can deserialize this data. Deserialize, for our viewers who are new to this term, deserialize is a jargon where we convert a raw formatted data, typically bytes or strings, into a dictionary. It can also be into a data class of sorts, but we'll cover that in a subsequent video. But for now, to deserialize this data into a dictionary, we can use the json.loads function. So to do that, let's quickly define data dictionary. This will be of type dictionary string to string. The string corresponds with the type of the key, and the second type parameter here corresponds to the type of the value. So over here to do that, we will do json.loads, and we'll pass in the raw data like this. We will also import the JSON library, and that's all. So once we have this data dictionary, we can finally change our server response such that it uses the name of that stock to return back the price of the call option. So let's quickly change our response. Let's call this stock, and this stock key and value will correspond with the same stock that was given to us by our user. So we do data dictionary followed by stock like this. And the second thing for now, for the purposes of this video, I'll be hard coding this to a static price of $100 like this. But that's pretty much it for our current changes to let our server get the stock that the user is interested in, like that. So let's spin up our server again. And this time, let's try passing in the expected input from our server. So let's call this stock. And let's say we want to get the call option price of Tesla, like this. So let's try making a request. And as you can see, the server now successfully handles the stock input from our user. So this was a very simple demonstration, but I hope that this was a clear demonstration of how we can handle the input from our user. So as an extension, this dictionary over here is nice and all. It lets us know what is the output from our user. But it would be better if we encapsulated exactly what that dictionary contains using data classes. So for that context, I'll be introducing a new library called pydantic. So from pydantic, import BaseModel. Pydantic is a library, a very popular library that is recently used to create data classes. And not only are they used for data classes, they also provide data validation and ensure that each of the inputs to the data class is of the correct type. So to demonstrate that to you, I'll be installing pydantic first. So as of now, at the time of recording, pydantic is 1.10.2. So let me add that into the dependencies over here. So now we have the base model class. Let's define a class that will encapsulate how the data should look like. So let's define a data class that encapsulates the input and output of this current route. So number one, it improves the readability. Our users, our fellow colleagues who maintain this service would not have to spin up the service and run this service just to get an understanding of how the data looks like. They can look at the data class blueprint itself to know what fields are there. So let's define two classes for now. The first one is for the input, so it will represent this input over here, and another one for the output. So to my understanding, Flask doesn't support pydantic data classes as a response out of the hood. So we possibly can't just return the pydantic data class as it is. But that's a lot of words for now. Let's get started. So let's first define the stock input. And we will make this data class extend the base model to inherit all of the cool functionalities that the base model provides us. So just like this, by making our class inherit pydantic's base model, stock input is now a data class. So the key in this case would be of type string. So that's pretty much it. So after we have loaded the data into a dictionary, we can convert this dictionary into an input by doing stock input of type stock input. This is a type hint. So stock input dot pass object. And this pass object over here would take in a dictionary like this. So if there are any errors, if the type of this is pretty much helping us do a data validation over here. If our user passes us a stock, but the stock over here happens to be an integer or not a valid stock ticker, then pydantic's data class would highlight that to us in a bit. So just like this, we have created our first data class that represents the expected input from our user. So just like this. So let's take a step back and spin up this server and try making a request to the server again. And as you can see, it works this time. But if we try to pass in an invalid input on behalf of the user, okay, in this case, pydantic actually converted the 100 integer into a string that is not expected. What would be a nice way to invalidate this? Let's say we pass in a dictionary instead. So let's call this stock Tesla, TSLA. This in this case would be not of the same type as string. Like our current input data class expects the value of stock to be of type string. So now that we pass in a dictionary, I will not expect this to work. This should invalidate. And as you can see, we get a 500 internal server error because you can see that pydantic has caught this type error for us. So you can start to see how valuable using Pydantic's base model is in creating data classes. They are very useful for us to validate the expected input from our user. Of course, returning back a 500 internal server error is not great. It would be nicer if we provide a more helpful error message, but for now, I guess this is good for all purpose for learning. So now that we have created our base model for the input, let's create one for the output. So class stock, let's call this call option price. Let's make this extend the base model as well. And similarly, in this case, this data class should share the same fields as what we are returning back over here. So this stock over here will be of type string, and the price will be of type float. So if we want to convert this, okay, this is the expected output, I guess. We can call this the call option price equals to call option price, stock equals to stock input dot stock, and the price will be equals to, let's say, 100, like this. So that's pretty much it. And I'm expecting this to fail because, to my understanding, Flask doesn't support Pydantic objects as a valid return. So I don't think this will work, but let's try this out and see if this works. So yes, we're getting a server error. Validation error for stock. Oh yes, of course, I forgot to change this to the right input. So now we have changed the stock value back to the stock name as expected by our server. Let's try running this. Okay, we still get an internal server error. And as you can see, Flask currently returns the view function did not return a valid response. The return type must be a string, dictionary, list, tuple with header or status, response instance, or WSGI callable. So in short, this base model by itself for Pydantic is not counted as a valid result or a valid output by the view function. This is really the view function, but this is pretty much the function that returns back the data when our user hits this endpoint. So to fix this, we can do dictionary. And this dictionary over here is part of the Pydantic base model class. So what this does is to convert this object of type call option price into a dictionary. So let's change this back to dictionary of a string and a string. Actually, no, that's not accurate. Let's just call this any. And the input will look something like this. Sorry, the output will look something like this. Stock will be Tesla, and the price will be float, some number. So like this. So yeah, that's pretty much how it should look like. Let's try spinning up this server again. I forgot to import any from typing. Let's try this again. And let's call the server. And as you can see, the server works. So frankly, the whole dance of creating two data classes for the input and the output is optional from the perspective of the client. But imagine that you are a software engineer working together with other software engineers. If you are to use data classes to encapsulate how the input from the user will look like and how the output of the endpoint should look like, this will give more readability to your other software engineers. For example, just looking at these two base models, you can tell what is the expected input and output from the user without having to look at this disgusting type hint, like what's a dictionary string any anyway. Like it's not very verbose on exactly what that dictionary should be containing. So anyway, I guess this is a good demonstration of how we cover two concepts. The first concept is how we can change our server to take in an input. And the second concept is we touched serialization and deserialization. Actually, to be specific, we touched deserialization. I don't think we touched serialization, actually, did we? No, we didn't. And if you are curious, the output over here is a dictionary. So this is not serialize to a string or a bytes. But the Flask framework will take care of that. Will take care of that in the subsequent parts of the whole request call. So that's why you do not see any steps for serializing this dictionary into a string or to a byte. And we also covered the concept of defining data classes to provide more readability and type safety to our input and output data class models. So I hope this was a helpful series. We'll be building on top of this and introduce more concepts as we go. And with that, we will see you in the next video. If you like this, please give us a like and subscribe, and see you in the third video.